Today we are going to discuss some of the problems on discrete time Fourier transform. First problem, find the DTFT of the signal x of n is equal to alpha to the power n into e of n, where mod alpha is less than 1. It is given x of n is equal to alpha to the power n into e of n, and we know that x of e power j o is equal to summation n is equal to minus infinity to infinity x of n into e power minus j o n, which is equal to summation n is equal to 0 to infinity alpha to the power n into e power minus j ohm n, which is equal to summation n is equal to 0 to infinity alpha into e power minus j ohm to the power n. Therefore, x of e power j o is equal to 1 divided by 1 minus alpha into e power minus j o. Next problem, find the DTFT of the signal x of n is equal to 1, 3, 5, 3, 1, and evaluate x of e power j ohm at ohm is equal to 0. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to expanding the summation x of minus 2 into e power j 2 ohm plus x of minus 1 into e power j ohm plus x of 0 plus x of 1 into e power minus j ohm plus x of 2 into e power minus j 2 ohm, which is equal to 1 into e power j 2 ohm plus 3 into e power j ohm plus 5 plus 3 into e power minus j ohm plus 1 into e power minus j 2 ohm, which is equal to x of e power j ohm is equal to 5 plus 6 cos ohm plus 2 cos 2 ohm. And also x of e power j ohm at ohm is equal to 0. If we put ohm is equal to 0 in the above equation, we get x of e power j0 is equal to 13. Next problem, find the DTFT of delta of n and draw the spectrum. We have x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to minus infinity to infinity delta of n into e power minus j ohm n. But delta of n is equal to 1 when n is equal to 0 and it is 0 when n not equal to 0. Therefore, x of e power j ohm is equal to delta of 0 into e power 0, which is equal to 1. Then the spectrum will be this ohm, it is x of e power j ohm, 0, pi, 2 pi, minus pi, minus 2 pi and so on. So amplitude will be one. Next problem, show that the DTFT of x of n is equal to 1 minus infinity to infinity. It is given by x of e power j ohm is equal to summation k is equal to minus infinity to infinity 2 pi delta into ohm plus 2 pi k. So we can draw x of e power j ohm as x of e power j ohm. It is 0, 2 pi, 4 pi, 6 pi and so on. Here it is minus 2 pi, minus 4 pi, minus 6 pi with amplitude 2 pi. It is 2 pi. Let us find the inverse DTFT of x of e power j ohm. To get x of n, then we have x of n is equal to 1 divided by 2 pi integration minus pi to pi x of e power j ohm into e power j ohm n into d ohm, which is equal to 1 divided by 2 pi and amplitude will be 2 pi into e power j of 0 into n, which is equal to 1. Therefore, x of n is equal to 1. If I take DTFT, I'll get x of e power j ohm, which is equal to summation k is equal to minus infinity to infinity 2 pi delta into ohm plus 2 pi k. Find the DTFT of the signal x of n is equal to minus 1 to the power n into u of n. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to 0 to infinity minus 1 to the power n into e power minus j ohm n, which is equal to summation n is equal to 0 to infinity minus e power minus j ohm into n, which is equal to 1 divided by 1 plus e power minus j ohm. So we will get 1 divided by e power minus j ohm by 2 into e power j ohm by 2 plus e power minus j ohm by 2. Therefore, x of e power j ohm is equal to e power j ohm by 2 divided by 2 cos of ohm by 2, where ohm not equal to 2 pi into k plus half, where k is equal to 0, 1 and so on. Find the DTFT of the signal x of n is equal to u of n minus u of n minus 6. It is given x of n is equal to u of n minus u of n minus 6, and we know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to 0 to 5 1 into e power minus j ohm n, or x of e power j ohm. After expanding the summation, we get 1 minus e power minus j 6 ohm divided by 1 minus e power minus j ohm. Evaluate the DTFT of the signal x of n is equal to half to the power n into u of n minus 4. It is given x of n is equal to half to the power n into u of n minus 4, and we know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. Therefore, x of e power j ohm is equal to summation n is equal to 4 to infinity half to the power n e power minus j ohm n, which is equal to summation n is equal to 4 to infinity half to the power e power minus j ohm to the power n. Then x of e power j ohm is equal to half to the power half into e power minus j ohm to the power 4 divided by 1 minus half into e power minus j ohm. Next problem. Compute the DTFT of the signal x of n is equal to 2 to the power n into u of minus n. It is given x of n is equal to 2 to the power n into u of minus n, and we have x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. Therefore, x of e power j ohm is equal to summation n is equal to minus infinity to 0 2 to the power n into e power minus j ohm n. Put m is equal to minus n, then x of e power j ohm is equal to summation m is equal to infinity to 0 2 to the power minus m e power j ohm m, which is equal to summation m is equal to 0 to infinity 2 to the power minus 1 e power j ohm to the power m, which is equal to 1 divided by 1 minus 2 inverse into e power j ohm. Therefore, x of e power j ohm is equal to 2 divided by 2 minus e power j ohm. Next problem. Find the DTFT of the signal x of n is equal to 1 by 4 to the power n into u of n plus 4. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to minus 4 to infinity 1 by 4 to the power n into e power minus j ohm n. Put m is equal to n plus 4, then x of e power j ohm is equal to summation m is equal to 0 to infinity 1 by 4 to the power m minus 4 into e power minus j ohm into m minus 4, which is equal to 4 to the power 4 e power j 4 ohm into summation m is equal to 0 to infinity 1 by 4 to the power into e power minus j ohm whole power m, or x of e power j ohm is equal to 256 into e power j 4 ohm divided by 1 minus 1 by 4 e power minus j ohm. dtft of the signal x of n is equal to a to the power mod n, where a is less than 1. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to minus infinity to infinity a to the power mod n into e power minus j ohm n, which is equal to summation n is equal to minus infinity to minus 1 a to the power minus n e power minus j ohm n plus summation n is equal to 0 to infinity a to the power n into e power minus j ohm n, which is equal to summation n is equal to 1 to infinity a into e power j ohm to the power n plus summation n is equal to 0 to infinity a into e power minus j ohm to the power n, which is equal to a into e power j ohm divided by 1 minus a into e power j ohm plus 1 divided by 1 minus a into e power minus j ohm. Therefore, x of e power j ohm is equal to 1 minus a square divided by 1 minus 2a cos of ohm plus a square. Find the dtft of the signal x of n is equal to alpha to the power n sin ohm naught n into u of n mod of alpha is less than 1. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. Therefore, x of e power j ohm n, x of e power j ohm is equal to summation n is equal to 0 to infinity alpha to the power n sin of ohm naught into n into e power minus j ohm n, which is equal to summation n is equal to 0 to infinity alpha to the power n e power j ohm naught n minus e power minus j ohm naught n divided by 2j into e power minus j ohm n, which is equal to 1 divided by 2j summation n is equal to 0 to infinity alpha into e power minus j into ohm minus ohm naught to the power n minus summation n is equal to 0 to infinity alpha into e power minus j ohm plus ohm naught to the power n, which is equal to 1 divided by 2j into 1 divided by 1 minus alpha into e power minus j ohm minus ohm naught minus 1 divided by 1 minus alpha into e power minus j ohm plus ohm naught. Therefore, x of e power j ohm is equal to alpha sin ohm naught into e power minus j ohm divided by 1 minus 2 alpha cos ohm naught into e power minus j ohm plus alpha square e power minus j2 ohm. Evaluate the DTFT of the signal x of n is equal to delta of 6 minus 3n. Sketch its magnitude and phase spectrum. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. Therefore, x of e power j ohm is equal to summation n is equal to minus infinity to infinity delta of 6 minus 3n into e power minus j ohm n. We know that delta of 6 minus 3n is an impulse function. Its time of occurrence is obtained by equating 6 minus 3n is equal to 0. Therefore, n is equal to 2. Then x of e power j ohm is equal to delta of 2 into e power minus j2 ohm, which is equal to e power minus j2 ohm because delta of 2 is 1. Therefore, magnitude of x of e power j ohm is equal to 1 and angle of x of e power j ohm is equal to minus 2 ohm. Then the magnitude and phase spectra for the one complete cycle, we can draw it as this is magnitude spectra. Magnitude is 1, this is ohm. It is 1 magnitude of x of e power j ohm. Minus pi is plus pi. And phase spectrum will be this is phase spectrum x of e power j ohm is 0, here it is pi is minus pi. It is minus 2 pi, here it is plus 2 pi. Evaluate the DTFT for the signal x of n shown below. Find the expression for magnitude and phase spectrum. X of n is given. This is x of n. 0 there is no signal, 1 there is no signal. At 2 we have amplitude 1. At 3 we have -1. At 4 and 5 we don't have any signal. And -1 also there is no signal. At -2 we have 1. At -3 we have 1. At -4 and -5 we don't have any signal. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. In the given figure, there are only 4 non-zero samples. That means at 2 we have 1, at 3 we have -1, and at -2 and -3 we have 1. Therefore, I can write x of e power j ohm as x of -3 into e power j3 ohm plus x of -2 into e power j2 ohm plus x of 2 into e power minus j2 ohm plus x of 3 into e power minus j3 ohm, which is equal to, all the amplitudes are 1 into e power j3 ohm plus 1 into e power j2 ohm plus 1 into e power minus j2 ohm plus minus 1 into e power minus j3 ohm, or x of e power j ohm. After simplification we get 2 cos 2 ohm plus 2j sin of 3 ohm. Then magnitude x of e power j ohm is equal to 2 into root of cos square 2 ohm plus sin square 3 ohm. Similarly, angle x of e power j ohm is equal to tan inverse of sin 3 ohm divided by cos 2 ohm. Next problem, compute the DTFT of the signal x of n is equal to half to the power n into u of n plus 3 minus u of n minus 2. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to minus 3 to 1 half to the power n into e power minus j ohm n. which is equal to summation n is equal to minus 3 to 1 half into e power minus j ohm to the power n. Put L is equal to n plus 3, then x of e power j ohm is equal to summation L is equal to 0 to 4 half into e power minus j ohm to the power L minus 3, which is equal to half into e power minus j ohm to the power minus 3 summation L is equal to 0 to 4 half into e power minus j ohm to the power L. Therefore, x of e power j ohm is equal to 8 into e power j 3 ohm into 1 minus half to the power 5 into e power minus j 5 ohm divided by 1 minus half into e power minus j ohm. Next problem, find the DTFT of the signal x of n is equal to n into half to the power mod n. Find the DTFT of the sequence x of n is equal to half to the power n alpha to the power n cos ohm naught n plus phi into e of n. We know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to 0 to infinity alpha to the power n cos of ohm naught n plus phi into e power minus j ohm n, which is equal to summation n is equal to 0 to infinity alpha to the power n e power j ohm naught n into e power j phi plus e power minus j ohm naught n into e power minus j phi divided by 2 into e power minus j ohm n, which is equal to half into e power j phi summation n is equal to 0 to infinity alpha into e power j ohm naught into e power minus j ohm to the power n plus half into e power minus j phi summation n is equal to 0 to infinity alpha into e power minus j ohm naught into e power minus j ohm to the power n, or x of e power j ohm is equal to half into e power j phi 1 divided by 1 minus alpha into e power minus j ohm minus ohm naught plus half into e power minus j phi 1 divided by 1 minus alpha into e power minus j ohm plus Ohm norm.